will now illustrate service management functions in NCS. In this case, I'm using queue and queue tunnels as an example. Note that the idea of NCS is to manage any type of service and a mix of service types at the same time, in the same way as we manage a multi-vendor device network. In this case, I have Cisco and PCAS in the network. At this point, I cold started NCS, so the NCS database is empty. However, the devices exist in the network and they have configuration. So to start, we have these devices. We've told NCS their IP address and how to authenticate to them. NCS can then discover the configuration in the devices. So you can say sync from devices. That grabs the configuration over whatever protocol the devices support. So for the Cisco's, for example, we're doing a show running config. We interpret that and populate the database. At this point, the whole system is re-rendered, so including the web UI, for example. I can click down into one of the PCAS and inspect its interfaces. And here we have the aggregate Ethernet interfaces and the gigabit Ethernet interfaces. So all of this is auto-rendered. If I plug another device, the web UI will be updated. NCS supports several northbound APIs and user interfaces. So far you've seen the web UI. NCS also supports a network-wide CLI where you can reach all the device configuration and service configuration in a unified CLI. It doesn't matter what the native APIs towards the device are. NCS has a unified CLI northbound, which actually displays and modifies the NCS database. Let's take a look at the CLI. Just a simple command. We're reaching the complete network, so I'm saying Cisco 0, 1 and 2 show me the interface config in one line here. So this gives you the interface config across 3 devices, and this is displayed from the database. You can of course do the same thing for the PCAS. And we change from Cisco to the PCAS, and here you see the PCA interfaces in unified format like this. This was displaying information in the web UI and the CLI. Let's move into configuration. In this demo we will focus on service management, but just for illustration purposes, let's do a very simple and basic device configuration operation. Imagine we would like to change the SNMP settings across devices. We can ask NCS to change for C0 to 22 its config, SNMP, server, the community string, and set it to goodcom. Here I did set it across 3 devices in one command. Here starts the NCS transaction engine. Nothing has been sent to the network yet. This is just internal to the NCS. What is the diff? NCS always performs a minimum diff to the network before executing the command. So in this case, none of the Cisco devices had a community string, so all of them will now have a new configuration item with the community goodcom. And we can commit that. Now that was sent to the network as a transaction. Imagine one of the devices would have failed, NCS would automatically roll back, and notice we can also roll back over simple CLIs without transactional support. In this case, an iOS CLI, we can do the reverse operations, moving it back to the original state. That's a rollback on failure. As a network engineer, you can also do rollbacks manually. Let's inspect the rollback files. We can do that in the web UI. So every command is stored centrally. So we see a couple of commands performed from the web UI. We see a command performed from the CLI. We can load that rollback file. This is the reverse. Since there was no community string previously, the rollback is actually to delete the configuration item. So we can load that and we can save it. Now a network-wide rollback across devices that naturally doesn't support rollback on its own. Device management is a topic on its own, as it has supports for device groups, templates with variable substitution, etc. But I will now move on to service management. So as I started, this example is about Q and Q tunnels. There is a Yang service model that defines what is a Q and Q tunnel, what are the attributes of a Q and Q tunnel. So when I ask NCS to create a service instance, it queries the user for the names according to the data model. It doesn't matter if I do it from the web UI, from the CLI, from a REST API, northbound of NCS, everything is data model driven. So I can call this customer 1 and an SVLAN. And let's add a couple of devices. And the service model specifies there should be a list of edge devices, edge interfaces, and CVLANs. Let's continue with the core. In the same way as I did in the CLI when I changed the community string, at this point we've just started a transaction internal to NCS. We have not yet sent anything to the devices. So we've populated an instance of a service model. If I would hit save in the web UI, the whole transaction engine, the mapping logic from this service model to the device data model, and the rendering of the southbound commands would happen. So I could just press save and make everything happen. But let's illustrate some capabilities of NCS. When you do things towards your network, you're quite often interested in what will happen before you actually commit it. So we have two kinds of dry run. You can do the default dry run, which shows you at the data model level what will be the changes. The native commit dry run shows you the actual commands to the device, so in the Cisco case, the CLI commands, etc. Let's start these two. First, the default dry run that shows you at the data model what will happen. So this is every green is new stuff, so this is the new stuff we will create on the PCAS, on the edge, and here we have the Cisco configuration in the core. Let's see what it means at the CLI level. So this will be the Cisco iOS commands to the Cisco devices. And save. Now this was performed as a transaction again. So the service instance, the device configs were written to the database, and the actual device configs were applied to the devices. And again, if something would have failed, nothing would have happened in the network. So this was creating a service. As I introduced previously when I talked about FastMap, the important thing is that NCS can manage the whole service lifecycle, and you can modify a service in any way. So imagine here that it was wrong SVLAN. We would like to change it. This is a simple change from a service model point of view, but you realize that there's a lot of config that you need to change on all the participating devices. NCS calculates these changes totally automatic. There's no code, no script, no definitions to an engineer that needs to express, if I change the SVLAN, what are the resulting actions? NCS derives that automatically. So we can, for example, do the commit dry run here. See that changing from that SVLAN value to another one. We could also inspect the CLI commands. So you see here what will happen on the Cisco device. Let's make it a bit more complex. Remove an interface as well. So we changed the SVLAN, we removed an interface. This would be fairly tricky to define manually what should happen. NCS does it automatically. So here we have the corresponding commit dry run. And we can save it. The service is now applied to the network. So this was a way of creating services in the web UI, just to illustrate the multiple various northbound interfaces. Let's do the same in a CLI. It's fairly interesting to actually realize that we have a service-aware CLI where you can manipulate and view services. So I have prepared a CLI sequence here, creating another service. You can see the diff. So we call this one customer 2. There are edge switches, edge interfaces, and edge switches like this. We can, from the CLI in the same way, do dry runs. We can use the native output, the actual CLI commands. And here we see the underlying Cisco commands, and we can commit it. Apply to the network. And you could do the same, for example, over REST, etc. We could look at a couple of interesting pieces of information that are available in the database. When you look at service assurance, for example, it's very important to understand the mapping between services and devices and vice versa. So firstly, let's ask NCS the devices, which services are they actually supporting? So this is a simple command to list every device in the network and the corresponding service instance. Another interesting thing is to look at a specific service instance, say customer 1, and look at this service. Which device configuration did it actually create? So we will see a perfect copy of the device information that this service actually wrote on the device. So we have pointers from the service down to the devices back to services. So let's look at a tricky failure scenario in the network. It's common that network engineers modifies device configuration directly, and when looking at the box you don't have a clue about what services are running and which device config is actually resulting from a service. So imagine we have a problem in the network, the tunnels are not working. NCS have an action that can check all the services in the network if the devices are configured accordingly. So the global action checksync checks all services, validates the device configuration if it's according to the service. And here it says that the service ID customer 1 is not in sync with the actual config on the devices. Let's analyze that. On a specific service, you can ask NCS to do a checksync and display a diff. What is the diff between the desired config and the actual config for the service to be working? And here we can actually see that someone has changed the port mode to access, and it should be port mode trunk. Remove port mode access and add port mode trunk. So NCS does a complete analyze how to restore the service, and you can redeploy the service back to the network. NCS will then do the minimum diff as displayed previously and make the service happy again, back restored. This removes a lot of tedious debug information. So that was restoring a service. Finally, a little bit on assurance and service impact. Since NCS has a perfect image of the device config and the corresponding services, let's say you have faults on the interface that affects a service, NCS can easily do that lookup. So let's simulate a couple of faults here, generating alarms. So I created spanning tree faults on interfaces. We can go to the alarm center and inspect the actual alarms. So on Ethernet 1.0 and 1.1 we had spanning tree errors on C0 and C1. NCS can easily do a lookup to see that customer 2 is affected and customer 1 is affected. And it's also displayed on the services here. They become red because NCS does the lookup. A fault on a port immediately affects a service. Thank you.